Welcome to Automotive EV. My name is Peter Wooding and thank you for joining us. Today we have episode 4 of our latest battery supply chain series. And joining me we have Jacqui Murray, Andy Palmer and Achim Glass. Achim is also moderating this session, so I will now hand over to him so I can sit back and enjoy what everybody's going to discuss. So it's yours now, Achim. Thank you.
Peter, thank you. Esteemed audience, drive electrification enthusiasts, Achim Glass of Kuehne+Nagel, the leader in logistics for zero-emission vehicles. The topic today is gigafactories in general and the demand and supply of battery packs. And what we would like to hear from our senior experts from the industry is what actually is happening inside the Gigafactory. And also we would like to drill down to the question of what is the contribution of Gigafactories with regards to achieving cost parity when it comes to the electric internal combustion engine vehicles. What are the major challenges inside and outside the Gigafactory? And with me today, we have two true industry experts. And since both of them have a very impressive curriculum, I would like to ask you, Jacqui, and you, Andy, to kindly introduce yourself to the audience. And ladies first, Jacqui, over to you, please.
Thank you. I'm Jacqui Murray. I'm Deputy Director of something called the Faraday Battery Challenge. It's really a UK government mission to leap us forward in the research, innovation and commercialisation of battery technologies. You may have heard of things like the Faraday Institution, Innovate UK's collaborative R&D, or the new UK Battery Industrialisation Centre that the Prime Minister opened, I think around about July time. And I guess my interest is really coming at it from creating sustainable, safe, high-performing batteries within the UK. Before that, weirdly, I was a steel worker and an environmental regulator. I had careers in both, 10 years on South Wales Steelworks and 14 years in the Environment Agency regulating heavy industry and transposing European law into British law.
Excellent, Jacqui, thank you very much. Andrew, over to you.
So good afternoon, everybody. It's a hard act to follow with Jacqui and her experience, but let me introduce myself. So Andy Palmer. I'm 42 years in the car industry. I know little other than cars. I'm a dead bore at a dinner party. Of that, 23 years were spent at Nissan, about 10 years heading up engineering in Europe. And then basically 13 years in Japan, eventually rising to become the chief operating officer of Nissan. Said in a quiet voice, reporting to Carlos Ghosn, which we don't talk about too much these days. Probably best known in that role for the architecture and delivery of the Nissan Leaf. So we can talk about a product that I was working on actually 15 years ago. And the difficulties of launching arguably the first modern day electric car way back then. After Nissan, I was 6 years in Aston Martin as the chief executive. That came to a conclusion 12 months ago. And over the last 12 months, I've been working on anything that one might call net zero carbon in the automotive world. So the most obvious role is vice chairman and chief executive of a company called Switch, which is Optare buses and Ashok Leyland EV division pulled together into a new company called Switch and responsible for bringing to market vans and buses, all net zero carbon around the world. I'm also vice chairman of a company called Innovate, which is a battery manufacturer based out of Slovakia. And I'm doing a number of projects, including helping a company called Punch try to acquire the Nissan factory in Barcelona so that we can bring to market hot hydrogen powertrains in a pickup application. So, as I said, all things net carbon zero.
Awesome. Andy, I would like to stay with you for a second. I know from your curriculum that you were based in Japan for a while, and you were significantly involved in the development and in the launch of the Nissan Leaf, the first electric car. And when I was looking and preparing for this session, I found on Wikipedia you're the godfather of drive electrification. I don't know whether you knew that or not. That you were being referred to that.
I'll put the pinstripe suit on next time in that case. I was certainly at the initiation of that program, pulling some nascent technology that Nissan had in its advanced technology labs and trying to put a business program around that, as well as solve some fairly significant technical issues in bringing basically the first electric vehicle of the modern era to market, and to bring it to market in Japan, US, and the UK, which obviously involved creating gigaplants or gigafactories in all 3 locations.
Mm-hmm. So back then, already 10 years ago, I assume that batteries were a large concern for you. It was the #1 thing that kept you up at night.
Oh, well, there was a lot of things that kept me up at night at that period of time, but batteries was certainly one of them, and refining a chemistry that we deemed to be safe and effective. And of course, there were no suppliers. So the technology had to be developed by Nissan. I was responsible for creating a joint venture, which was eventually called AESC, which was a 50-50 joint venture with NEC. NEC essentially provided the anodes and cathodes, and Nissan essentially took responsibility for what one might broadly call the Gigafactory, which was the slitting through to the various dry rooms and eventually creating the pack. Yeah, it was a difficult time. We used a chemistry called LMO, which is lithium ion manganese oxide, which was a pretty stable material, because we didn't want to have any mishaps. And I think the Leaf has been blessed with basically not having any mishaps over its life. It's not particularly energy dense, but it's safe. We created something that was in all other respects like an internal combustion engine car, because we didn't want to give people lots of reasons why not to buy it. We wanted to make it a fairly simple transition from gasoline or diesel over to electric. And so we ended up initially with a 24 kilowatt hour battery, probably too small, but we were still, we were guessing. It wasn't anything called range anxiety back then, because the problem hadn't existed. So that was sizing the battery, considering the energy density of the battery, thinking about the charging infrastructure, which was clearly an issue, but probably just the simple point of making the darn thing in 3 locations was both expensive and difficult, and Nissan sunk about $4 billion into the launch of that vehicle.
Mm-hmm. Wow. Well, also, obviously, 10, 15 years ago, lithium-ion batteries existed in a long time in consumer products, whether it's tablets, laptop computers, or smartphones. And therefore, there's no surprise that the Samsungs and Panasonics, those consumer good brands, they also were responsible for the manufacturing of the batteries. But as we all know today, the lithium-ion battery market is really dominated from Asian companies. They are still Japanese and Korean companies, the traditional ones, but it's Chinese companies with CATL, leading the pack, by far the largest producer in the world. However, now we have Northvolt, Britishvolt, or the recent announcement of Nissan and Envision building a Gigafactory in Europe. I have 2 questions for you, Andy, and then we're handing over to Jacqui. What comes to your mind when you hear Gigafactory? Because this expression didn't exist 5 years ago. That will be the first question. And the second question is, if possible, within say in 60 seconds, what happens inside the Gigafactory? So what comes to your mind when you hear Gigafactory, and what actually happens inside the Gigafactory?
Okay, well, I think Gigafactories probably is a misconception. It's a battery that's capable of creating 1 gigawatt hour battery capability, but the reality is that is relatively small when you think about the global demand for batteries. Probably today, if I was talking about building a factory, for example, in the UK, and British Volt, for example, I think they're talking about a 30 gigawatt factory, so it's not a gigawatt. In fact, the first battery that I built in Sunderland, which is now in Vision, as you said, was basically a 1 gig factory. So it is a bit of a misconception, but basically what we're talking about is enough batteries to feed what will ultimately be most of the cars made in British or European factories. So you need, in simple terms, you need a lot of them, and a gigafactory consumes an awful lot of energy in the manufacturing of the vehicle. A dirty secret, of course, is if you don't use sustainable energy, then basically you simply move some part of the CO2 problem to the manufacturing of the battery. So you've got to put those factories together with sustainable energy. In terms of what I define as a gigafactory in 30 seconds, but basically it's not possible to easily source cathodes and anodes in the UK at the moment, or indeed in Europe. So generally speaking, they're coming from the east. We have to solve that problem. So I'm not dodging it. That has to be solved. But basically, if I think about the gigafactories that I was responsible for, they start with a roll of cathode and anode coming into the factory, and the first operation is the slitting and stacking of those units. You then basically take it through a couple of basically dry rooms and add the necessary materials required to create the pouch or the cylinder or the prismatic form factor. Then you basically do some form of assembly into a module, age that module, and eventually put them into a pack. So in the Nissan definition, it starts with slitting and it ends with a pack. In other definitions, it may start with slitting and end with a pouch. So sometimes the packing is done elsewhere. And as we look to the longer term, we have to solve that issue of let's say localizing cathode and anode, because they're such an intrinsic part of the value chain.
Agree. Andy, thank you very much. Jacqui, over to you. You are also a chartered engineer, but I do understand that your relationship with batteries is of a different nature. So as a deputy director of the Faraday Battery Challenge, you're helping to lead government investment to develop batteries. Can you tell us more about the Faraday Challenge? And similar to the question to Andy, what comes to your mind first, Jacqui, when you hear Gigafactory?
Yeah, so let's start with the first bit. I'm sure Andy's got a view on this. So I am an engineer, and the problem that I'm sort of charged with solving is of making a vehicle a profitable, successful, commercially attractive vehicle. It's really about the whole system for the UK. It's really about how you get people wanting to invest, wanting to produce raw materials, wanting to develop technologies, wanting to do the science. So it's huge, right? And so it's a very big and fuzzy problem that you need to try and solve. And so a lot of what Faraday Battery Challenge is doing is actually not telling people the answers, but really owning the problem and working alongside a lot of players, right? So it's lovely to hear Andrew talking, because I sit alongside lots of other automotive leaders, giving information into the Faraday Battery Challenge and us advising and working with government. So actually that we get the best return for the money, that we can support private investors, for example, making decisions on very capital intensive decisions. So you can sort of see it's this real ecosystem, this innovation ecosystem that we're trying to set up in the UK. In terms of what comes to mind for me when you talk about gigafactories, okay, and for those listening, if you want to really know what goes on in a gigafactory, I recommend you get hold of UK Big. The Battery Industrialization Centre is a fully flexible 1 gig gigafactory, and you can go there and see just how continuous the processes for manufacturing cells, or just how fast the winding process is, and just how energy intensive the drying processes are, and also, you know, all the design parameters that you would have for module and pack. So for anyone in the industry wondering actually how they could get their heads around it from an engineering point of view, go and see UK BIC. Even I wanted to go and get hands on with part of it. But what comes to mind really is it's a keystone for my problem. So if I really want the UK to leap forward, we can sponsor science and we can sponsor innovation and we can have a commercialization centre. But it's actually attracting those gigafactories to the UK that sort of gives you this keystone in the supply chain. It means that all the materials can start to flow in, and people can really make some investment decisions or strategic decisions in companies. You know, the chemicals industry in the UK is actually bigger than the automotive industry, so actually you can start to see some of those major investments going on there. On the other side, you can see actually things like recycling is really important. So I sort of think about gigafactories as this key bit. And unlike Andy, I don't really think about setting them up, but I do think very heavily around how we can make the UK a very, very exciting place for perhaps some joint ventures, perhaps some sort of syndicated investment decisions from whether they're Far Eastern companies or they're American or whatever else in the UK. I then have to sit and think a bit harder really about some of those challenges that gigafactories face. So if I really want to have an innovation ecosystem that actually works, I need to be really conscious around what procurement managers need. You know, they need sustainable sources of energy at a decent price. They need quality materials, and the materials make up such a huge proportion of the cost of batteries. I need sales departments who are happily demonstrating that they meet the rules of origin, so that they can supply into the major market of Europe, for example. And I need HR departments in a gigafactory, you know, easily finding skills and talent that's trained, or they have ways to train them to move them up. And finally, just a nod, I guess, to my 14 years in environmental regulation. I need the Air Environment Department to have ways to get those recycled, maybe working with Kuehne+Nagel in the future. But actually, how do those end of life systems work? So I guess that's where my head goes when you talk to me about gigafactories.
It's extremely vast area, okay, of things which come to your mind. Thank you, Jacqui. And we have a question for you with your very, very strong automotive background and now your engagement in Switch. You mentioned before that there's a dependency on cathodes and anodes from Asia, and we all see every week additional announcements from European car manufacturers about more and more volumes coming into the market. But we also realized, and we know, and also research based on our own Kuehne+Nagel activities, that we still will depend on the supply from Asia probably until 2030. And only as of 2030 onwards, there will be enough gigafactory supply coming out of Europe, which will actually allow us Europeans, or allow the Europeans, to export cells to other markets. But in the meantime, what do car makers, EV car makers do in order to ensure stable supply of batteries? Can you share some of your strategies, maybe from your own organization or from what you heard in the market?
Yeah, let's address the first issue as that timeline. As became manifestly clear through the Brexit agreement, there is a rule of origin requirement, which requires us basically to have 70% local content, means European content, of batteries for vehicles being sold in Europe by 2020, as I said, by 2026. And if you drop one level deeper than that, it's 65% local content at the level of the cell, which means, to all intents and purposes, you've got to find a solution to that anode and cathode problem. 2026 in automotive terms is tomorrow, and you know, basically, as the famous saying goes, if you wanted to get there, you wouldn't start from here. It's too short. Now, obviously, Europe had rightly acknowledged the problem of dependency on Asian and in particular Chinese sourced batteries. It can see the value chain diminishing, the engines disappearing, and the 40 to 50% of the value of the vehicles being made in Europe basically potentially were coming from Asia and potentially coming from China, which of course, let's be honest, that was China's intention. Europe has been very clear in creating this this project of strategic importance, and it's only the second project in Europe to carry that title, which has created this requirement to localize batteries and localize them quickly. And the net result of that is that EIB and local governments are investing enormous amounts of money in order to attract manufacturers, be they existing Asian suppliers or be they startups, Northvolt being the obvious startup, and of course Innovate in Central and Eastern Europe, just to put a plug in there. There is an enormous tension to get these battery manufacturing capabilities up and running. Whether or not we get them all there, and whether or not we can meet the local content requirements remains to be seen. As I said, 2026 is really around the corner, and it's a ramping curve. It ramps up to that 70% local content, but failure to do so means that there's a risk that you have to pay tariffs on the cars that you're selling in Europe. There is a risk if you meet all of those requirements. There are two risks as I see it. Risk number one is eventually you may end up with overcapacity because somehow you've got Europe, Asia, and US all competing with each other. So the worst case is you get into a sort of boom and bust, as we see with silicon chips at the moment. So that's something to be cautious about, but that's not today's problem. The other problem is that it's difficult to see how any of those inward investments come into the United Kingdom. The United Kingdom, makes over 1 million cars a year. It employs, I think, 865,000 people. And if we don't have battery factories in the United Kingdom, my hypothesis is that we don't have car makers in the United Kingdom 10 years from now. So that's nearly 1 million people that you basically lose their job. And it's as existential as that. And whilst Europe has, I think, been quite smart in creating the tension to localize and localize quickly, and it's working because basically almost every battery manufacturer has announced an intention to manufacture in Europe. The UK is sitting there passively, assuming somehow or other these gigafactories are going to magically pop up somewhere, and they won't, and they won't, and they won't. You won't get that to happen unless you have proactive intervention into the whole value chain that assures at least the likes of British Volt have half a chance of succeeding. Jacqui was nodding there, which is encouraging.
Yeah, I don't think we think it's an easy challenge. And I do have some very, very hardworking colleagues around us, Andy, that actually at least manage inquiries in a much more slick way. We're such a interconnected cross-government thing, Faraday, and cross-partners like the APC and even the Aerospace Technology Institute and others, and WMG and CPI and people you'll know really well. There is a real purpose to what we're trying to do here. I can't speak on behalf of the Chancellor. I think that probably would be pushing my job description. But I think, if you ever want to pick up the phone to senior ministers, please do, Andrew, because for me, where we sit, it's so ripe for it. Just small signals. UK BIC, for example, the support it got from the Environment Agency and local authority to get its permit, the amount of people that just want to transfer and come and work for them from adjacent industries and train up. Even in my team, I'm seeing people really desperate to really get into this field because it means something. And for me, I just think we have a sort of global duty all that skills that we have, Andy, all that leadership that we've had over the last, you're from auto, right? You can get nostalgic too, right? But we're very good at making cars move. We're very good at design, and there's a reason Nissan stay. I think it's because, you know, they enjoy working. And I did Japanese technical exchanges when I was on Steelworks. They enjoy working and being challenged by British engineers, and British engineers do well being challenged by Japanese systems thinking. And I think there's a lot of synergy there, and I think we do have to front up and be leaders in this space. And whilst we may never become the volume manufacturers on lithium ion cells, you can see things like actually sodium ion, solid state. The costs of those are much more comparable to make those here to elsewhere. So actually there is something to sort of potentially aim for. And in the meantime, as we learn and we develop, and you see so much expertise come and you know, make progress here, you can see actually it does get to the point where it's funding that comes to the heart of it. And it's not just public funding, right? You know, I actually don't think we're looking for 20 years of funding from government. I think actually what we're really looking to do is give enough commitment that really reassures and provides incentive to those big players looking at Europe here and now. But I think it's something that will become self-sustaining relatively quickly, because I think, you know, we have those sorts of abilities here.
Jacqui, I completely agree with you. And the UK is marvellously innovative. And I can say that even when I was sitting in Japan and looking at things like autonomous technology being developed at Oxford University and the various lithium-ion battery stuff that was being developed here, the issue for us has never been one of lack of brain power, lack of innovation. It's always been this valley of death where you take the great idea and you move it through to the exploitation. And the Koreans and the Japanese and the Chinese have all been much quicker, for example, to pick up on, but both on AI and autonomous driving and lithium batteries, and run with it much more quickly than we have. And that is a funding issue, because the capability is here. And here we're not, at least I'm not saying that, you know, suddenly state has to put, you know, everything into it for forever. I mean, you just need to level the playing field, nothing more than that. I mean, government, generally speaking, tends to take a laissez-faire approach, and a business will somehow fix it. Well, business will somehow fix it, but at least you need to level the playing fields. If you're getting massive incentives in the EU, then you need to have massive incentives in the UK, just to level the playing field. After that, you also need to find a reason why you would build in the UK. Supply chain and shortening the supply chain is part of the answer, but in the same way that the EU regulated local content, perhaps there needs to be the same thing for the UK, that there needs to be some form of guidance, regulation, availability of incentives, but insofar as you take batteries from the UK. Otherwise, all of those car companies are simply going to buy from cheaper sources in Europe, and you won't create the infrastructure that you need, and you do need the infrastructure to look at sodium batteries and solid state, because they're a progression from where you are today. So it is an existential issue from my point of view. The Treasury, BEIS, all of us need to look at solving it. Otherwise, we can kiss goodbye to the rest of our car industry. On the contrary, if we can solve this, it's a huge opportunity, because we do have the residual talent in innovation in the country already proven, and if we can use that and exploit it, we can do really well of this so-called build back better.
Mm-hmm.
So I think there's something about the severity of this market failure. You know, we talk about 2008 sometimes internally, Andrew, around that catastrophic financial crisis. But actually what we're facing here is a crisis with a timescale that actually makes this almost impossible for car companies to have the cash flow to invest. In fact, I'd suggest it is impossible for them to do that. And that's really where government should be involved, right? Where there's market failures that you can see companies through and industries through, where they can come back round and actually be successful in the future. And I'd suggest if we do lose all that, Andrew, we probably, as the world, will have a slower route to electrification of transport, and that would be an absolute crime.
Andy, you mentioned before you were referring to the 1 million vehicles which are being manufactured in the United Kingdom today. And today we have 2 gigafactories announced. So clearly there's an undersupply. I lost my train of thought now. I wanted to ask, with regards to this undersupply, what was my train of thought?
Well, we certainly need more factories. That's without question.
Yeah, the question was along the timelines. Even if there was a lot of money available from the government today, you don't build like the Wuhan hospital over the weekend. You don't build a gigafactory. No. Does any one of you have any ideas about the timeline? Let's assume that you have the land available, and we do see this in Scandinavia, in Norway, and also in Sweden. Close to the water, they have wind energy, they have a lot of water energy. I suppose many more factories will be popping out of the ground over there. How long does it take to build a gigafactory?
Start now. You could probably have something available in 2025 earliest.
Mm-hmm. That is depends on the procurement of equipment, doesn't it, Andy?
Yeah, it does. And everybody, there are only 1 or 2 major suppliers of equipment, and you have to book slots with them, and there's a lot of competition to get them. Interestingly, of course, Chinese companies are often responsible for the equipment that goes into these factories. But that, as you said, that's making an assumption that the land's available. And actually, the problem isn't really the land. The problem is basically access to energy. Battery manufacturing consumes an enormous amount of energy. And there is virtually no land available in the UK at the moment that has sufficient grid capability to sustain a gigafactory. The most obvious one is Blyth, and our friends at British Volt, of course, have chosen that location, but still have to build a factory. So there's still a lot to do, and that normally means also making sure that you've got an order book that sustains it, because you've got to borrow money against your order book to make it happen. But if you assume that that's number 2, then you still, according to government sources, need 4 to 6 of these types of facilities in the UK. It's not easy to find places where you could put them. I can think of 1, maybe 2 places where you'd consider putting gigafactories right now, and neither of them tick all of the boxes. They all need to be worked. So, but basic problem is, if you could start now, if you could break ground now, you could perhaps have a gigafactory in 24, 25, but you can't break ground now because there isn't the land available. So you're already pushing up around that cutoff timing of 2026. And I agree with Jacqui. It looks almost impossible.
Correct. So then,
whoa. I have to step in, Andy. That point is well known. And actually, there is a team that have been doing a lot of work. So if you, Andy, when you're out there and you suddenly decide you want to build your gigafactory, come talk to us, because there's a team in DIT that have actually done a lot of the legwork on the ground and available sites in the UK. You're right, there's not many, because the scale of them can be huge. I mean, British Volt's footprint will be one of the biggest buildings in the UK or Europe, but actually for me, it is a challenge. There are things we're good at in the UK. Actually, we kind of run ourselves down. We can do some of the planning stuff in advance. We can do permitting. We can get some of those things that actually really do slow these projects down and are probably big risks, right? So we're lucky with Faraday that it's sort of created a bit of that chaos that a gigafactory would produce on a smaller scale, so that you've got the Environment Agency working very closely already with British Volt. They're not surprised by a gigafactory. They've got regulatory position statements and understanding already in train.
Earlier this week, US Rivian announced that they will also now go into battery manufacturing, and we have seen similar announcements from other EV companies. Is this a desperate try to support to ensure that there can be a supply of batteries because the OEM believes the tier one supplier, the battery manufacturer, will not be capable in doing that? Will that be enough? Or do you think, will they be successful or will they not be successful? Because do they have the competency to really build batteries, or will they just do the pack assembly, or will they really build the cells? Because they will have the same problem as we were just discussing before. The cathodes and the anodes are not available because that is clearly something out of scope today. So it all comes back to the raw material and to these crucial elements. Let's forget the separators for the time being, but cathode and anode production.
Well, how did Andy do it at Nissan? I'm really intrigued, actually. You're talking about building the Leaf. What was it that made you want a factory for the batteries next door rather than just buying batteries in from Japan or China?
Also, we were developing it in Japan, obviously, so we had the relationship with NEC, but from our point of view, we couldn't get the form factor that we really wanted for the Leaf, which was a pouch form factor, and we didn't believe that going down sort of commercially available cylindrical form factor was the right solution for us. So the only solution to that was to make our own. There was also at that time, certainly was a key part of my philosophy of thinking, was that the battery represented, well, now it's 40 to 50% of the value of the car. Back then it was even more, and so to outsource such a huge part of the revenue of the vehicle to me didn't feel right as a car maker, and therefore, whilst we knew we couldn't do it ourselves, we didn't know how to make cells. We needed to do it in partnership, and that was the rationale behind what became AESC. Interestingly, at that time, about a year behind, Renault was developing its Zoe, and the philosophy there was to use external cells, and they ended up buying external cells from LG. And somehow through the course of the alliance, actually my very last executive committee at Nissan, there was a decision to make to start to step back and see battery as a commodity. I was very vocally against that because it's not a commodity, it's an intrinsic part of the vehicle and the behavior of the vehicle. What you're seeing now, of course, is as car companies have either accepted the inevitability of moving to EV, or they've found Jesus, whichever you believe in, and they're basically, we're now on a clear course to introduce EVs almost entirely into the passenger vehicle segment. That all of the car companies are saying, hey, we need to get closer to the battery manufacturers, and therefore you're seeing very close collaborations. For example, VW and Northvolt, for example, PSA and ACC, and I think that's an inevitability that they're not a core skill of the car manufacturers, but they're a really important part of the supply chain. And what you can't afford to have is something like the silicon chip issue that you have today. You need to have security of supply, and therefore the collaborations that exist.
Okay, so can I ask Achim a question?
Of course.
From a logistics point of view. So we've seen Tesla invest in a mine, and we've now seen Glencore take a stake in Britishvolt. And I think it's sort of to Andy's point, right? It's about learning how the hell that's all going to operate, because we don't really know. And when you outsource that, you lose, at the beginning in particular, you lose a lot of understanding and potentially a lot of the value. So you've got this space. So what about logistics companies? You're big companies. Where do you see, how are you getting your learning on batteries? How are you going to move in this space? Because we always talk about government funding, because obviously that's what I do. But I'm really interested in some of those private sector strategic thoughts at the moment.
Okay. Well, it's back in 2016, 2017, when the first car makers and tier one suppliers actually approached us and said, how can we transport batteries from Asia into Europe or into North America? Because there was not sufficient supply available in this part of the world. And but maybe some of the audience does not know that actually lithium-ion batteries are considered a dangerous goods, a hazardous goods commodity, and it's not easy to transport them. And if you pinch them, you drop them, or there's a mishandling, there's a high risk of combust, explosion, and fire. And the fire you can actually not extinguish. So to transport these batteries is not easy. And this is why we started many, many years ago. And our mind was around how can we transport millions and millions of cells, of whether it's cylindric or round or pouches, from Asia into Europe. And I don't want to say it has become a commodity, but there are certain routes and certain carriers which do accept that commodity, subject to significant safety measures and requirements. My company prides itself on being one of the leaders in transporting those cells by all modes of transport. But in the meantime, we have also evolved because the end of life has become more and more of a subject for us and a topic for us, because we see those before mentioned Zoes and Leafs coming back from the aftermarket, and we need to transport the batteries for second life or for end of life. And that has become an even bigger challenge for the logistics companies as well as for the car makers. So to Kuehne+Nagel, this is a very nice niche. It's a segment, but it's not easy to handle, because you do require special investments into infrastructure for fire safety measures. You need special investments to monitor the jungle of legislations which are out there, because depending on the mode of transport, you are choosing, well, there's a different legislation, different dangerous goods regulation, which you need to adhere to. And the differences in regulations require different packaging requirements, different limited quantities, et cetera. So to navigate through this jungle is complicated. And if you fail to meet those policies, you are subject to paying very, very high fines. And also life is at risk, obviously, when you mishandle those batteries. But to us, actually, nowadays, more and more car makers and battery suppliers are turning to Kuehne+Nagel in order to ask us, how can we transport a battery pack from Portugal to recycling, knowing the next recycling plant is 3,000 miles away, because there is no lithium-ion battery recycling plant available in Portugal. This means you have to transport hazardous waste across borders. And that is extremely complicated, and the truth is as well, it's extremely expensive. It's not sustainable. So the truth is, we're also sending trucks from Europe all the way to Scandinavia. We pick up 2 batteries and we bring them down to Germany, to France, to Belgium for recycling. Today, it's still possible, but looking into the millions of batteries which will come from the aftermarket, it's not a sustainable solution. So also here, legislation needs to do something. And we developed over the years, we learned, and we are partnering up with industry stakeholders, such as recycling companies we are working with, in order to come up with a safe, reliable, and scalable solution. But it is a big problem, and it will not be easy to resolve, and it is expensive.
Come on, then, what's Kuehne+Nagel going to do?
Sorry, I didn't get you.
So are you planning on working with recyclers, with battery packaging, with the regulators? What's the?
I mean, with regards to regulators, we happen to be the largest sea freight and air freight company in the world. So obviously, we do work with regulators as well, because they ask us for advice. We work hand in hand to make the industry better, a little bit better every day. The majority of customers who are shipping, storing, and transporting lithium-ion batteries are the who of the battery manufacturing industry, predominantly Asian companies today. Obviously, tier 1 suppliers, which are building battery packs, but the car makers alike. In the past, the battery manufacturers were controlling the supply chain. Now the car maker would like to take ownership of the supply chain. They would like to be in control, so they have become our clients. But yes, we do talk to recyclers as well, because the recyclers, there are recyclers who say every day when there was not a fire at our premises, it's a good day, because they receive batteries wrongly labeled, wrongly packaged. And once again, this is a dangerous commodity. Airplanes came down, ships have been on fire. I mean, people died because of mishandling of batteries. So it's a serious issue. And in our organization, it's safety first, And again, that comes along with educated people, a lot of training, awareness training, training on the jobs, and money because the fire
so maybe we'll have
safety
you
measures.
Maybe we'll have you in a future safety project or recycling project. Yeah.
Very, very happy to do that. Very happy to do that. Peter, I know that I see you're time concerned over here. We had 45 minutes already, but I would like to give Andy and Jacqui the opportunity to make a final comment, or ask a last question. Is there anything where you said, I still have this on my mind, I would like to mention that when it comes to gigafactories, the supply and the demand of battery packs? You know, it's such a topic you can talk for hours about it. And the idea today was to give our listeners a flavor of how complex it is and how interesting the entire topic is for many, many people.
No, I would close by reiterating that it is a very complicated industry with an enormously complicated supply chain. But it is also an inevitable part of transportation. And look, there are always going to be the fanboys and girls of electric versus the fanboys and girls of hydrogen. The fact is, no matter any of those technological solutions, you end up with a lithium battery somewhere, or eventually maybe a solid state battery in the vehicle. So batteries are a part of the future. They're an intrinsic part of vehicles in the future, and that vehicle might be a motor car, but it might also be a vertical takeoff and landing vehicle. In every aspect, battery is important, and if you're part of that industrialized world and a part of your GDP is dependent upon transportation, then solving the conundrum that we've talked about is absolutely vital, and we shouldn't think of it as a problem to be solved in the future. It's here and now.
Thank you, Andy. I see, Jacqui, you're nodding your head. Anything else from you, Jacqui, before we give back to Peter?
No, I think maybe because I'm not man and boy automotive industry, I think just for people listening in, it is complex and it is a massive challenge, but it is what's going to make the world better for your grandchildren or your great grandchildren. But once you're actually in it, it's much more familiar than you'd imagine. Mm-hmm. So I think as engineers, I always thought I'd be a lifer on the steelworks, and that you're very hemmed into one sector, and actually batteries is not that far away. It is a common technology for so many sectors. There'll be somewhere that is very, very familiar to you within the battery sector. So do reach out if you're interested in UK BIC, if you're interested in joining the Battery Innovation Network, for example. Come and talk to practitioners, because joining standards and health and safety and environmental standards, just join in. Because what you'll find is a bunch of engineers or scientists or insurers or whatever, right, who speak your language and are not, as Andy said, like, the evangelists. They're actually the doers, and they're there now, and you can come and talk to them.
Great, very, very good. Dear Jacqui, dear Andy, thank you very much for your time. I would like to hand back to Peter.
Thank you, and thank you, Jacqui, thank you, Andy, and thank you, Achim. Really interesting and informative session, and quite frankly could have run on and on for much longer, but it's good to leave people wanting a little bit more rather than desperately rushing out for a coffee. So fabulous session, thank you very much indeed. On behalf really of everybody who's watched live, I thank you from them, and also the number of people that will catch up on demand who hasn't been able to actually tune in during this part of the day. So on behalf of as an automotive EV and all of our excellent panelists, thank you for watching. Don't forget there's another episode of our battery supply chain series next week, and if you've heard about this from someone, don't forget it's all available on demand, so you can catch up soon. So thanks again, everybody. Thanks for your time. Bye.
Thank you.
Bye.
Goodbye. Thank you very much.
Hi, it's Peter again, and thank you for watching the session. Don't forget you can connect with all members within the EV community. send messages to each other, and start to build relationships for the future. Also, take a look at our supplier showrooms. Our partners have got lots of products and services that they have to offer, which again could be of benefit to you. Make the most of the opportunity, and thank you again for joining us.